Let's say we are writing a program that models a restaurant with an instance of a baker class that can bake different types of baked goods. The baker needs to be able to make cookies, brownies, cupcakes, donuts, and a whole list of treats. So we need to create an efficient way for our baker to cook all of these recipes. In our baker class, we write out a bake brownie method that takes in a brownie and calls a method from the brownie class called bake on it. Then we write another method called bake cookie that takes in a cookie and calls a method from the cookie class called bake on it. Looking at the code, we realize we're repeating ourselves, and since cookies and brownies are similar, it would be more efficient to somehow factor out this shared functionality and have just a single method that can take in any baked good and bake it. This may not seem like a big deal for just 2 baked goods, but consider a baker who needs to bake a couple dozen baked goods. Luckily for us, Java provides us with a helpful tool called an interface that takes advantage of the shared functionality between classes. Interfaces in Java allow us to model functionality that we want many different classes to share. Since all of our baked goods can be baked, we can model this shared functionality by creating a bakeable interface. We first need to learn how to define and use interfaces. We create interfaces much like we create classes in Java in their own file. But rather than using the class keyword, we write public interface bakeable. Like classes, interfaces also declare methods. However, while classes have defined instance variables and concrete methods, interfaces are highly abstract. They can only declare methods, but not define any code for these methods or for any instance variables. For example, if we want our bakeable interface to contain a bake method, we would write placing a semicolon after the parentheses and not writing a method definition. It is important to note that interfaces act as a contract. This means that when a class declaration states that it implements an interface, it promises to have the functionalities declared in the interface by defining all of the interface's methods. If a method declared in an interface is not defined in a class implementing that interface, the compiler will raise errors. Now, let's make our baked good classes implement this bakeable interface. In our cookie class, for example, we will revise our code by adding the implements keyword and the name of our interface. By declaring that our cookie class implements the bakeable interface, the cookie class must define every method declared in bakeable. To define a method from an interface, we will need to override the abstract method. We will do this by including the @override keyword right above our method declaration and definition. We then can declare the bake method, making sure that its return type and parameters are the same as the abstract bake method from the bakeable interface. Let's say for cookies, we want to bake crispy chocolate chip cookies. In the cookie class, we can define the bake method like this. However, maybe for brownies, we want to create super fudgy frosted brownies. In this case, when we define the bake method in the brownie class, we would write this. Now let's go back to our baker class and make use of our new interface. We want to replace our bake cookie and bake brownie methods with a single new method called bake dessert that can take in any baked good and bake it. Java allows us to use our interface as a type, so we can define a method that takes in any instance of type bakeable. Since the bakeable interface has a bake method, we can call that method on our parameter. Then, when calling this method, we can pass in any class that implements the bakeable interface. Because we know that every class that implements bakeable will define a bake method, we have a guarantee that we can call the bake method on any bakeable instance. So in our restaurant class with our baker, we can do this, and the bake method from the cookie class will be executed. Then we can do this, and the bake method from the brownie class will be executed. Notice that in our variable definitions, we are defining the type of the variable as bakeable instead of cookie or brownie. This is called polymorphism, and it's when we reference an instance using a generic type, such as an interface, that allows us to treat different instances of different classes in the same way. Using interfaces in polymorphism allow us to write efficient code and take advantage of the similar capabilities of the classes we are creating. For more information, reference the Interfaces in Polymorphism lecture slides or the lab handout.